Nearly 100 videos are telecasted for those who love subject the most. All such great math lovers are requested to subscribe this channel, like, comment and share with your friends, family members who are students or FSC or metric.
Part number 5 is 1 plus ex power 3 by ex. First we expand cube and numerator a cube plus b cube plus 3ab a plus b divided by ex dx. Then it is 1 plus, we can write e3x, but yet we are writing ex cube. Then we write 3ex 1 plus ex dx. Then we divide it, or first we just simplify numerator a little more. Numerator simplification is 1 plus ex cube plus 3ex plus 3ex square divided by ex dx. Now we divide 1 by ex. We split this fraction ex cube by ex, 3ex by ex, 3ex square by ex dx. This is cancelled and power becomes 2. This is cancelled. One of them is also cancelled. And then we separate integration also. E minus x dx. E2x dx. 3 outside, or integration of 3 dx. 3 outside, integration of ex dx. What is integration of exponential function? Exponential function integration is itself divided by derivative of power. E2x integration, e2x divided by derivative of power is 2. Integration of 3 is 3x. Integration of ex is ex plus c. So this becomes finally minus e minus x 1 by 2 e2x plus 3x plus 3e power x plus c. This is answer. Then we have part number 6. What is part 6? Part 6 is sine a plus b x dx. Integration of sine is minus cos with same angle a plus bx divided by derivative of angle. Derivative of angle is a plus b plus c. So it is single step integration. It's completed. Then we have part number 7. What is part number 7? Part number 7 is integration square root 1 minus cos 2x dx. Now again it doesn't match with those basic forms. We will have to transform it. So in place of cos 2x we can write 1 minus 2 sine square x. This is replacement of cos 2x. Cos 2x has three forms. One of them is 1 minus 2 sine square x. It's used as replacement here, and so this one is cancelled by this 1 minus 1, and now what it is? Square root 2 sine square x dx, and root remains on 2, and square root 2 shifted outside, and integration of sine outside root, it is sine x dx. Integration of sine is, right now we have seen, minus cos. It is also completed. Part number 8 we see now. And part 8 is also a single step question. Natural log of x multiply by 1 by x dx. Derivative of natural log of x is 1 by x, which is written with it, so we increase power of function by 1. So function is natural log of x, its power is 1, we add 1 to the power and divide by that. This is integration. Its integration is also single step integration. So this is finally 1 by 2 natural log of x whole square plus c. Then we do integration of part number 9, integration of sine square x. Only solution for sine square cos square is their half angle or double angle identity. This is equal to 1 minus cos 2x by 2 dx. If we write 1 by 2 outside, then it's integration of 1 dx and integration of cos 2x dx. Integration of 1 is x, integration of cos 2x is sine 2x by 2 plus c. Now we do part number 10. Part number 10 is integration 1 by 1 plus cos x dx. We make single term in the denominator. How can we make single term in the denominator? If we see cos 2x, because of this conversion, cos 2x is equal to 1 minus 2 sine square x. If we take 2 sine square on this side, it is positive obviously. 2 sine square x equal to 1 minus cos. So this doesn't match with it. 1 minus cos doesn't match. This doesn't match. If we write the other form of cos 2x, which is 2 cos square x minus 1. Shift 1 on the other side. 1 on this side is positive. So 1 plus cos 2x it becomes equal to 2 cos square x. Then if we replace x by 2, replacing x by 2, we have this 1 plus cos x, and here we replaced x by 2, so its replacement forms this. X by 2 appears on right hand side, and on left hand side it was 2x, that becomes x2. So 1 plus cos x equal to 2 cos square x by 2. So we replace it here. 1 by, we write it 2 cos square x by 2 dx, and then we take 1 by 2 outside integration, and cos in denominator makes secant in numerator, secant square x by 2 dx, and integration of secant square is tan x by 2 divided by derivative of angle 1 by 2x, derivative is 1 by 2 plus c. So we see that this is at second place, this is at third, though both are cancelled, so finally it is tan x by 2 plus c. Next is part number 11. Integration ax plus b divided by ax square plus 2bx plus c dx. So students, if you differentiate denominator, it becomes 2ax, which can be made in numerator by multiplying by 2. So if we multiply numerator by 2, it becomes 2ax plus 2b, which becomes derivative of denominator. So denominator is function, numerator is derivative. That form we can make by multiplying by 2 and dividing by 2. So multiplying by 2 makes 2ax plus 2b. Division by x is shown as 1 by 2 outside integration. This remains unchanged. Ax square plus 2bx plus c dx. And then we see that this is function with 1 power. And numerator is derivative. So integration is natural log of the function. Function is ax square plus 2bx plus c. We write integration constant c prime here. After that we have part number 12. What is part 12? Integration cos 3x sin 2x. There are two functions here. Here angle is not same. That is why we transform it into product. So for that we multiply by 2, we divide by 2. We multiply by 2. It is 2 cos 3x sin 2x dx. Then it is 2 cos sine. What 2 cos sine equal to? We know this formula. Product to sum formula. So 2 cos alpha sin beta. 2 cos sine is equal to sine minus sine. Sine minus sine is 2 cos sine. Formulas are sine plus sine 2 sine cos. Sine minus sine 2 cos sine. Cos plus cos 2 cos cos. Cos minus cos minus 2 sine sine. So if you see product which is on right hand side, what it matches with? 2cs second. So corresponding to it we write sine minus sine. So this is sine alpha plus beta minus sine alpha minus beta. If we transform it into the other form, then it becomes sine minus sine. Sine alpha minus beta sine alpha plus beta sine alpha minus beta. So this is 2 cos sine equal to sine minus sine. Here it is 3x plus 2x alpha plus beta. Here it is 3x minus 2x. So then we separate integration sign also. 1 by 2 integration of sine 5x dx and minus 1 by 2 integration of sine x dx. 1 by 2 integration from outside, this is sine 5x, this is sine x, and now we evaluate integration. Integration of sine is minus cos 5x. We also divide by derivative of angle, which is 5. Here it is minus 1 by 2, derivative of sine is minus cos x. Plus c we add, and now we can keep 1 by 2 common, so it is 1 by 5 minus 1 by 5 cos 5x plus cos x plus c. This is integration. It was a little maybe you can say complicated, but This is the solution. Now we have two short questions left in it. Let us solve them now. This is number 13. Integration cos 2x minus 1 divided by 1 plus cos 2x dx. In place of cos 2x we write 1 minus 2 sin square x. It is replacement, this is minus 1 divided by, here we write 1 plus cos 2x. We have used this formula earlier also. 1 plus cos 2x is equal to 1 plus cos 2x is equal to 2 cos square x. So we write directly that form here. Two cos square x dx. So 1 cancels 1 here, 2 cancels 2 here, sin square by cos square is tan square. So minus tan square integration is to be done here. So tan square is not in those basic forms. We transform it using identity. Identity says tan square is secant square x minus 1 dx. And then we write minus integration of secant square x dx, and this becomes plus integration 1 dx. Secant square is derivative of tan, so its integral is tan x, plus integration of 1 is x plus c. So this is also done. Number 14. What is 14? In 14 we do this tan square x dx. We transform tan square, as it doesn't match with the basic form, we write it secant square x minus 1. Basic forms are written on page 125 of the book, Punjab textbook board mathematics book. So this is secant square x dx minus integration 1 dx. Secant square is derivative of the function, so its integral is that function. Secant square integral is tan x. Integration or integral of 1 is x plus c. This is answer. So this exercise is completed. Integration tan x dx. We can write it in the form sin x by cos x dx. We know that derivative of cos is minus sin. So we write minus sin in numerator, 1 minus sin outside integration, 1 with sin. So derivative of cos is minus sin, we can see in numerator. In denominator it is function with 1 power. In numerator there is its derivative. In such a situation, natural log of function, cos is function, minus sin is derivative. In such situation, natural log of function is integration. So if we use log property, this minus 1, which is coefficient of log, becomes power of cos, and it becomes 1 by cos x, and we know that 1 by cos is secant. So integration of tan x is natural log of secant x plus c. This is answer. Students, we have to prove integration dx by square root x square minus a square is equal to natural log of x plus square root x square minus a square plus c. First, we identify this form. If we can see this closely, we are unable to find any of such form from page 125 of FSE Part 2 book. Page 125 shows us some basic forms. It doesn't match with any of those basic forms. It means we will have to first transform it into basic form. So in order to transform, we in fact want to remove the square root from here. We use trigonometric substitution. In place of x, we write a secant theta. X will be replaced by a secant theta, then its differential is dx is equal to a secant theta tan theta d theta. As we know that the derivative of secant is secant theta tan theta, so same as the differential, and dx is equal to a secant theta tan theta d theta is differential of left hand side and right hand side of the substitution. X is equal to a secant theta. Now we consider the given form integration dx by square root x square minus a square. We make those replacements. Dx is replaced by a secant theta tan theta d theta, and x is replaced by a secant theta. It becomes a square secant square theta minus a square. A square can be taken common from denominator, then it will become secant square minus 1. Secant square becomes tan square. Secant square minus 1 becomes tan square. A square tan square removes the root, and root and square are cancelled, so we have a tan theta in the denominator. A tan theta from numerator cancels out denominator a tan theta, and we have to integrate simply secant theta. Natural log of integration of secant is natural log of secant plus tan plus c prime we write. And now where we make substitution, we can see that x is equal to a secant theta. If we take a on left hand side, then it becomes secant theta value x by a. Definition of secant is hypotenuse by base, as definition of cos is base by hypotenuse. It is reciprocal of cos, so has inverted form of the definition of cos. Cos is base by hypotenuse, secant is hypotenuse by base. This is how we can find h is x, hypotenuse is x, base is a. By using Pythagoras theorem, we can find perpendicular. It is square root x square minus a square. As we know that h square is equal to p square plus b square, from that we find p is equal to square root x square minus a square. From here we have all these hypotenuse, base and perpendicular. We can define tan. Tan theta is perpendicular by base. Perpendicular is x square minus a square square root by a. This will be tan theta. So now we can make replacements. Natural log of secant is x by a. Tan is square root x square minus a square by a plus c prime. Then we can take LCM a. A is LCM. So natural log of x plus square root x square minus a square by a plus c prime. And then we use log property. Property of the logarithm is natural log of x plus square root x square minus a square minus natural log of a minus natural log of a plus c prime. C prime minus natural log of a. Natural log of a is a constant, c prime is a constant. Both will make another constant c. So natural log of x plus square root x square minus a square plus c. This is the integration of this given form, which this form did not match with the basic form. We then make substitution, trigonometric substitution, in order to remove the root. When we removed the root, we found secant theta to integrate, and we integrated that. It matches with the basic form. Its integration is natural log of secant plus tan plus c prime. Then we converted this theta form in x form using substitution equation. So this is the solution, student.
Nearly 100 videos are telecasted for those who love subject the most. All such great math lovers are requested to subscribe this channel, like, comment and share with your friends, family members who are students or FSC or metric.
Exercise 3.2, question number 1, part number 4. It is integration 2x plus 3 power 1 by 2 dx. How we integrate this? We convert it into a form where function is written with derivative with it. Function is written along with the derivative. So we multiply by 2 and we divide by 2. So division by 2 is shown as 1 by 2 outside. Integration and multiplication by 2 is shown with the function. So it is function with some power and along with it is its derivative. When such a situation arises, we do integration of the function as we increase power of function by 1. We add 1 to the power of the function and divide by that value. So 1 by 2 is the power of the function. We added 1 to it and divided by that value plus c is added. Here it is 1 by 2. 2x plus 3 power, it becomes 3 by 2 divided by 3 by 2 plus c. This 2 is cancelled by this and we see that 1 by 3, 2x plus 3 power 3 by 2 plus c is answer. So it is simple integration and is completed. Next part is number 5. Part number 5, what is there in it? It is again same kind of the function, square root x plus 1 whole square. Same rule is applied everywhere in these parts. That function along with the derivative of function is written with derivative with it. So function power is increased by 1 and we divide by that. This is the rule we are following in this integration. Now here again we expand the whole square as a square plus b square plus 2ab dx. Then we write this becomes x plus 1 plus 2 square root x integration. Now we write integration separately with all of them. We write integration sign separately with all of them. Integration x dx, integration 1 dx, 2 outside, integration square root x dx. Then students, it is same situation where function has derivative with it written. X is the function, derivative is 1, which can be considered in product. So we increase power of function by 1. Power of function is 1 and we add 1 to it and divide by that. Plus integration of 1 is x. Here also x is with 1 by 2 power. So power of x is increased by 1 and we divide by that value plus c. So then we have 1 by 2 x power 2 plus x. This becomes 2 times x power becomes 3 by 2 divided by 3 by 2 plus c. And finally we write about it 1 by 2 x square plus x. From third place 4 rises to first makes 4 by 3. X power 3 by 2 plus c. This is answer in this case. Next is part number 6. In part 6 we have integration square root x minus 1 by square root x whole square dx. First we expand this whole square as a square plus b square plus 2ab. The square root x cancels square root x, square cancels root. So we have at both these places we have integration x plus 1 by x plus 2. We write integration sign separately. Integration x dx plus integration 1 by x dx minus integration 2 dx. Then we see that integration of x is, we add 1 to the power of x as derivative 1 is can be seen along with it as in product. So integration is function power increased by 1 and division by that value plus this is derivative of natural log of x. So its integration is natural log of x minus integration of 2 is 2x plus c. Then we have 1 by 2 x square plus natural log of x minus 2x plus c. This is answer. Next we do seventh part. Let us do part number 7. It is integration 3x plus 2 divided by square root x dx. We write this separately, 3x by square root x and 2 by square root x dx. Then we can write it can be written as 3 integration these two power of x power 1 minus 1 by 2 it is. Denominator power 1 by 2 will be subtracted from numerator plus 2 integration. Here it is x power minus 1 by 2 dx. Then we evaluate integration. This is 3 integration x power 1 by 2 dx plus 2 integration x power minus 1 by 2 dx. Now we increase again in the same pattern as we did previous parts. We increase power of x by 1 and divide by that value plus 2 times. Here when power of x is added it becomes 1 by 2. Now how it is simplified? This is 3 by 2 in the is written in denominator. So it will be 3x power 3 by 2 divided by 3 by 2. 3x power 3 by 2 divided by 3 by 2 plus this is 2x power 1 by 2 divided by 1 by 2 plus c, and finally it is this 3 is cancelled by this. So 2 rises to first place. So answer will be 2x power 3 by 2 and 4 square root x. It will be 4 square root x plus this is answer. We will do another part, number 8. Part number 8 is integration square root y plus 1 by y dy. We have to do this y plus 1 divided by these two y get simplified. Square root y and y makes square root y in denominator here. Then we separate it. This is y by square root y plus 1 by square root y dy. And then y power 1 by 2 y power 1 minus 1 by 2 dy plus integration y power minus 1 by 2 dy. We proceed in it. Integration y power 1 by 2 dy plus integration y power minus 1 by 2 dy. Then we integrate as derivative of y is 1 with respect to y it is 1 written with it at both places. So we just increase power of the function by 1 and divide by that value. If we increase the power it becomes 3 by 2 and the denominator is 3 by 2, so that becomes 2 by 3 as coefficient. So here power 1 by 2 denominator also becomes 1 by 2, that becomes 2 in numerator plus c is added as the integration sign ends. Integration is calculated. Now we will do another part, number 9. Integration square root theta minus 1 whole square by square root theta d theta. First we expand whole square. A square plus b square minus 2ab divided by square root theta d theta. Then this is theta. Now we separate it. Theta by square root theta 1 by square root theta 2 square root theta by square root theta whole square. This is cancelled. These two also get cancelled to make square root theta in numerator. So this simplifies as square root theta in numerator d theta. We separate integration sign with all of them. Theta power minus 1 by 2 d theta plus integration 2 d. Now we evaluate integration. How will we do? Its integration is power of theta is added because derivative of theta is 1 written with it. With respect to theta, its derivative is discussed. Theta derivative with respect to theta is 1 written with it. Power of theta is increased by 1. So power already is 1 by 2. We increase power by 1 and divide by that value. Plus here again theta power minus 1 by 2 as derivative is written with it. We increase power of theta by 1. Integration of 2 is 2 theta plus c. C will also be added to it. This is theta power 3 by 2 and in denominator we have 3 by 2. Here theta power 1 by 2 is divided by 1 by 2 plus 2 theta plus c. Then we finalize it as 2 by 3 theta power 3 by 2 plus 2 square root theta plus 2 theta plus c. This is answer. Now we will look at next part. Integration 1 minus square root x whole square divided by square root x dx. It is a square plus b square plus minus 2ab. A is 1, b is square root x divided by square root x dx. So what is it? This is 1 minus x minus 2 square root x divided by square root x dx. We separate integration to all minus 2 outside square root x divided by square root x. This will be integrated. Here integration x power 1 by 2 dx. Here these two are cancelled, integration 2 dx. So then we every time increase power of the function by 1 and divide by that. So x power function power is minus 1 by 2 increased by 1, x power 1 by 2 plus 1, 1 by 2 plus 1 minus 2x, and then we have x power 1 by 2 divided by 1 by 2 becomes 2. So here is x power 3 by 2 divided by 3 by 2. 3 by 2 in the numerator becomes 2 by 3 minus 2x plus c. Next is last part of question 1. It is integration e2x. It is exponential function plus ex divided by ex dx. We split this fraction. We write it ex power 2 by ex plus ex by ex dx. Then we have this is cancelled with it. These two will also be cancelled. So what we have, integration ex plus 1 dx. Integration of ex is ex. Integration of 1 is x plus c. This will be answer. Integration square root x plus 1 by square root x dx. We write first these two x with power 1 by 2 and we separate integration sign also, x power minus 1 by 2 dx. Now as derivative of x is written with it 1, this x as derivative 1 written with it, we can consider 1 in product. So that allows us to write its integration. Integration is whenever function has derivative with it written with it in product, we increase power of the function by 1 and divide by that value. So we increase power by 1 by adding 1 to the power and divide by the same value, plus x power minus 1 by 2 plus 1 divided by minus 1 by 2 plus 1. After integration we add c, which is constant of integration. This can be written as x power 3 by 2 divided by 3 by 2 plus x power, it becomes 1 by 2, this is also 1 by 2 plus c. So then it is 2 by 3 x power 3 by 2 plus this becomes 2 and this becomes square root x plus c. This is answer. This was second part. Now we move to third part. X square root x plus 1 dx. We distribute this x which is outside with it, so it becomes x square root x plus x dx. Then we write integration sign separately. Powers of both x has been added. Integration sign is also separated. Then again same thing. 1 is derivative of x which is with it, as we can consider it in product with these both 1. So their integration is that power is increased by 1 and we divide by that value. We add 1 to the power and divide by that value. Here also 1 plus 1 divided by 1 plus 1. Also we add constant of integration c with it. This becomes x power 5 by 2 divided by 5 by 2 plus x power 2 by 2 plus c. So finally we can write it as 2 by 5 x power 5 by 2 plus x square by 2 plus c. This is answer.
Nearly 100 videos are telecasted for those who love subject the most. All such great math lovers are requested to subscribe this channel, like, comment and share with your friends, family members who are students or FSC or metric.
This is question number 2. Question number 2, its part 1 and 3 are similar. These are same parts. We will have to rationalize denominator because this doesn't match with any of those basic forms written on 125 page FSC part 2 book. So here it is x plus a plus x plus b. We cannot write its direct integration, right? We will have to transform it into a form where this matches with those basic forms, and then we will be able to integrate. So for that matter, we rationalize denominator. So rationalizing denominator, we have to multiply and divide by a quantity which is conjugate of the denominator. It is square root x plus a minus square root x plus b. We multiply and divide by this quantity dx. Then what we do, numerator multiply by 1, it means that unchanged value square root x plus a plus square root x plus b, and denominator we can see that it is written a plus b, a minus b. So a plus b, a minus b make a square, means x plus a square root square minus x plus b square root square dx, and then root and square are cancelled. What will we have in the denominator? This is square root x plus a square root x plus b divided by, we have x plus a minus x minus b dx. Then we see that this x is cancelled and a minus b remains in the denominator, which can be shifted outside as 1 by a minus b. And then we separate integration sign. Integration of x plus a square root can be written as x plus a power 1 by 2 dx, and integration x plus b power 1 by 2 dx. Then we know that this is function and its derivative 1 can be considered with it. X plus b is a function, its derivative 1 can be considered as in product with it. So if such a situation where is function and along with it is its derivative, we add 1 to the power of the function. So power of the function is 1 by 2, we add 1 to it and we divide by that. Here again x plus b, in x plus b case this is function and derivative 1 is with it, so we add 1 to the power of the function and divide. Here integration is completed, so we just simplify it now. 1 by a minus b, it is x plus a power 3 by 2 divided by 3 by 2 plus x plus b power 3 by 2 divided by 3 by 2 plus c. And then if we take this 3 by 2 outside, it becomes 2 by 3, and we have x plus a power 3 by 2 x plus b power 3 by 2 plus c. This can be answer. So we can bring entire solution before us also. Let's look. We multiply and divide by the conjugate or denominator to rationalize it. So we rationalized, and then denominator simplifies as a minus b. We take it out as 1 minus a minus b, and then we separate integration on x plus a whose power is 1 by 2 and x plus b whose power is 1 by 2. So x plus a derivative is 1 written with it, x plus b derivative is 1 with written with it. So when there is a function and derivative is written and product with it, we add 1 to the power of the function and divide by that value. So x plus a power 3 by 2, so we divide by 3 by 2, and x plus b power 3 by 2, we divide by 3 by 2. We take 3 by 2 from denominator common, it becomes 2 by 3 in numerator. From third 2 rises to first place, so 2 by 3 a minus b and this becomes answer. Part number 3 can also be done by the same method, and now we move to do another part. Part number 2, integration 1 minus x square 1 plus x square dx. This is improper rational fraction. Improper rational fraction case tells us that divide first. So by division, what will we have? If we divide 1 minus x square by 1 plus x square, we will have to multiply by minus 1. So it is minus 1 minus x square. If we write plus sign here, and x square cancels, this become 2. So by division this is equal to, we write answer first plus remainder by divisor. This transforms into this form and dx. Now we separate integration 1 dx and 2 outside. If we write, then integration 1 plus x square dx. After that, integration of 1 is x. Integration of this 1 by 1 plus x square, as it is derivative of tan inverse, so its integration is tan inverse of x. As our claim doing integration is that from derivative we bring function, so derivative is 1 by 1 plus x square, and corresponding function is tan inverse of x. In the next part, we do integration of the fourth part. In fourth part, we have to integrate a minus 2x power 3 by 2 dx. So in order to create its derivative along with it, we multiply and divide by minus 2. So multiply by minus 2, division by minus 2 is essential here, and we did. A minus 2x is function, minus 2 is its derivative written along with it. If such a situation is there, then how integration is calculated? We just raise power of function by 1. We add 1 to the power of function and divide by that value, plus c, this will be answer. So then it can be simplified as 1 by 2 a minus 2x power 5 by 2 divided by 5 by 2 plus c. From second 2 cancelled by third, so it is 1 by 5 a minus 2x power 5 by 2 plus c. Integration sine theta by 1 plus cos square theta d theta. This integration, this function which is to be integrated, does not match with any of the standard forms written on page 125. So we first try to match it with one of those standard forms. And how can we match it with those? We converted this trigonometric form into algebraic form by substituting cos theta is equal to y or t or something, right? If we substitute, then what happens? We have to calculate its differential also. So its differential is minus sine theta d theta is equal to dy, and then the value of d theta is dy by minus sine theta. After it, we make this substitution. Given form is here. This is given form. Integration sine theta by 1 plus cos square theta d theta. This is equal to integration sine theta by 1 plus cos has been called y, so it becomes y square. And what d theta is equal to? It is equal to dy by minus sine theta. Sine theta cancels sine theta. Then what we have? We now obtained this form. 1 by 1 plus y square dy, and this minus sign will also appear along with this integral. Now this is the form matching with those basic forms. It is not written on 125 page, but it is one of the basic form. How is it a basic form? Because this is the derivative of tan inverse, so its integration is tan inverse of y. Tan inverse of y plus c we write, and what y is, we bring back y, so it becomes tan inverse of y. Y is cos theta plus c. This becomes answer. So answer of this integration, sin theta by 1 plus cos square theta d theta as this. So this is answer. This has been done. The entire solution can also be brought before you. This is the entire solution. By converting it into algebraic form, 1 by 1 plus y square dy, it matches with the basic forms where it becomes the derivative of a function. So it is the derivative of a function. That function is its integration. It is derivative of tan inverse, so tan inverse is its integration. Tan inverse of y plus c. So we can replace y by cos theta. So you see that question is in theta variable, answer is in theta variable. Exercise 3.2, question number 1, part 1. It is integration 3x square minus 2x plus 1 . This is simplest question of integration. We can shift this integration sign to each one of them. Integration 3x square dx minus integration 2x dx plus integration 1 dx. Then we shift coefficient outside integration. Then we can shift constant coefficient outside integration. There is no variable, so 1 remains in this form. Then we calculate integration. How can we calculate derivative of x as 1? We can consider it is along with it and product with it. So then we add 1 in the power of x and divide by that value. This becomes integration. Same is the case here. Derivative of x we consider is here 1, which can be seen in product with x here. If there is derivative of x along with it and product with it, then we add 1 to the power of x and divide by that value. This becomes integration. Plus integral of 1 is x, as derivative of x is 1. These two are, 1 is derivative, 1 is integral. We know that derivative of x is 1, so integral of 1 is x. Plus c will also appear 3x cubed by 3 from numerator and from denominator get cancelled. Similarly 2 from numerator and denominator get cancelled, and this becomes answer. X cube minus x square plus x plus c. This is answer of this integration. Now this integration completely is before you. I hope you can understand it. एक्सरसाइज 3.2 का क्वेश्चन नंबर 1 और उसका फर्स्ट पार्ट है। ये पहला जो केस है इंटीग्रेशन का,
उसके अकॉर्डिंग ये सॉल्व होगा। इसमें लिखा हुआ है 3x² माइनस 2x प्लस 1 अंडर dx, इसको इंटीग्रेट करना है। ये पोलिनोमियल फंक्शन है। याद रखें स्टूडेंट्स, इंटीग्रेशन में पावर इंक्रीज होती है, डिफरेंशिएशन में पावर डिक्रीज होती है। ये क्वाड्रेटिक है, इसका आंसर क्यूबिक पोलिनोमियल आएगा इंटीग्रेशन का। और अभी आप देखें इसमें क्या लिखा हुआ है। पहले तो इंटीग्रेशन हम सेपरेट कर लेंगे, हर पार्ट पे अलग अलग इंटीग्रेशन लिखेंगे। 3x² पे इंटीग्रेशन, माइनस 2x पे इंटीग्रेशन, प्लस 1 पे इंटीग्रेशन सेपरेट कर देंगे। इंटीग्रेशन साइन और dx, ये कंप्लीट इंटीग्रेशन साइन बनता है। इंटीग्रेशन 3x² dx, इंटीग्रेशन 2x dx, इंटीग्रेशन 1 dx, ऐसे लिख देंगे। फिर 3 को आउटसाइड, 2 को आउटसाइड शिफ्ट कर देंगे। और x² के इंटीग्रेशन है और x की इंटीग्रेशन है। तो x² के इंटीग्रेशन आप देखें, x² के साथ 1 मौजूद है प्रोडक्ट में। 1 तो आप कहीं भी प्रोडक्ट में कंसिडर कर सकते हैं। तो x² के साथ 1 में प्रोडक्ट में मौजूद है, इसका मतलब है x का डेरिवेटिव 1 साथ मौजूद है। जब डेरिवेटिव साथ मौजूद है तो पावर में एक ऐड करते हैं और डिवाइड करते हैं। पावर 2 है, उसमें एक ऐड करेंगे, 3 बनेगा, उसी से डिवाइड करेंगे, -2। अब देखें x की इंटीग्रेशन, x का डेरिवेटिव 1 साथ मौजूद है तो इसकी पावर में भी एक ऐड करेंगे। x की पावर 1 है, 1 + 1 डिवाइडेड बाई 1 + 1 हो जाएगा। प्लस 1 की इंटीग्रेशन x है, क्योंकि x का डेरिवेटिव 1 है, प्लस c लिख देंगे। अब देखें दो डिनोमिनेटर ऐसे बन रहे हैं जो कोफिशिएंट के साथ मैच कर रहे हैं। 3 कोफिशिएंट है, 3 डिनोमिनेटर है कैंसिल, 2 कोफिशिएंट है, 2 डिनोमिनेटर है कैंसिल। तो हमारे पास ये आंसर आ रहा है x³ माइनस x² प्लस x प्लस c। दिस इज आंसर स्टूडेंट।
इंटीग्रेशन natural log of x dx, natural log of x integration 1 dx minus integration 1 dx derivative of natural log of x dx. Natural log of x as it is, integration of 1 is x, integration, this integration of 1 is x, this derivative of natural log of x is 1 by x dx. X and 1 by x are cancelled, so natural log of x and x are in product like this. Integration of 1 is x plus c. This is answer. This integration is integration by parts, can be seen easily. One function, it is natural log of x whose direct integration is not there. We consider 1 in product with it, and then we integrate it using by parts formula. Bismillahirrahmanirrahim. Assalamu alaikum students. We are solving exercise 3.2 and it's question number 1 part 1. As we know that it is integration 3x² minus 2x plus 1. All these questions can be done using same method. What is this method? Let's look. We write 3 outside first and write integration sign with x², then 2 outside integration sign is with x, and integration of 1 dx. After that students, we consider x derivative 1 with it in product, like it is here, like it is here. So x derivative 1 is here and product with it. So we increase power of x by 1. Power of x is 2. We add 1 to it and divide by the same value. This is integration. Minus same thing happens for this. X derivative is with it written in product. So we add 1 to the power of x and divide by that. Plus integration of 1 is x. Also we write c with it. constant of integration. Now we write final statement. 3 is cancelled with 3, 2 is cancelled with 2, so answer will be x cube minus x square plus x plus c. This is integration of given function.
Integration x natural log of x dx. If we use isolate, I stands for inverse, L logarithm, A algebraic, T trigonometric, E exponential. So the function which comes first is logarithmic. We make it fixed that whenever we see log or inverse trigonometric function, they will be called first function and will be written outside integration. This integration will also be done by parts formula. If we see natural log ever in integration, we write that, we consider that first function, and we will write that outside integration. So natural log of x integration of x dx minus integration x dx derivative of first function, which is natural log of x, and integration of this under dx. So now we evaluate this. How is it evaluated? Natural log of x, integration of x is x square by 2, integration of x is x square by 2, derivative of natural log of x is 1 by x, and it will be integrated again. This x will be cancelled with one of the x in numerator. Then we will see what happens. 1 by 2 x square, natural log of x minus 1 by 2, integration x dx. So once again integration of x is under discussion. 1 by 2 x square, natural log of x minus 1 by 2, integration of x is x square by 2 plus c. So finally we have, if we write it 1 by 2 x square, natural log of x, we can take 1 by 2 x square common also and can write in this form also, minus 1 by 4 x square plus c. This is answer.
Bismillahirrahmanirrahim. Students, we are solving FSE annual paper of 2021, and it's short question number 8 we have, where we have to show that y is equal to 10 ex plus c as solution of this differential equation. As we know already, students, that an equation in which derivative of dependent variable with respect to independent appears, that equation is called differential equation. So here we can see y is dependent, its derivative with respect to x is shown, dy by dx is shown here in the equation. So this is differential equation, and its solution we have to show y is equal to 10 ex plus c. So let's move towards solution. Dear students, solution is here. First we separate variables. So given form is dy by dx is equal to y square plus 1 by e power minus x. In denominator we can see e power minus x. We can bring it in numerator where it will be e power x. So dy by dx left hand side is unchanged, right hand side e power x will be shown in numerator in product with y square plus 1 numerator value. After that we take y square plus 1 on left side under dy. Dy by y square plus 1 is on left side is equal to ex is already on right side. We bring dx from left side on right hand side. So from left side dx on left side dx was in denominator and right hand side dx will be in with ex and product and numerator. Now we can see students that entire y variable expression is on left side, x variable expression is on right side. That means variables have been separated. This kind of differential equation where variables can be separated is called variable separable form. So this variable separable form where variables have been separated. Now the next step is integration. We integrate both sides. For integrating both sides, we apply sign of integration. So integration of left hand side dy by y square plus 1 and integration of right hand side dx. Left hand side we can see that 1 by y square plus 1 is derivative of tan inverse. We know that derivative becomes function due to action of integration. So integration converts the derivative into function. We know that 1 by y square plus 1 is derivative of tan inverse. So integration of 1 by y square plus 1 is tan inverse of y. Most of you know this already. Ex integration is ex because ex derivative is ex plus c will also appear with independent variable. We know that x is independent variable. On its side we write plus c and then we keep y on left side. Tan inverse on left will become tan on right. So tan of ex plus c becomes right hand side and this becomes answer. So dear student, as we knew already that this we had to show that a solution of that differential equation and we found y is equal to tan ex plus c as its answer.